Okay, let's continue the studies by by focusing on the per unit system. Here is a very useful example of the per unit system. So I need your full attention to check how we can do the analysis using the per unit system. Okay, step one, obtain per unit system impedance for this simple power system. Single line diagram is given. Uh, the base system is it given? The transformer here, the transformer. I think I missed the transformer values chosen as a base for this system. So as you can see here, the system is 11 kV to 132 and then 132 to 11 kV. The values V base can be whatever you like, is 132 or 11, and the other one which is S is 50. Okay, before starting of this system, when we have a transformer in the system, we should see that one, the transformer make the voltages in two different level, correct? So usually I suggest to my student to make a line between transformer. So right now, as we have two transformer, we have three different section. So for the transformer, as you can see, the generator voltage is 11. So this part of transformer is 11 kV. So we choose V base for the section 1, which is here, equal 11 kV. Then for this system, again using transformer, which is 132. So 132 kV equal V base in the section 2. And finally, again, 132 in the transformer, change it to 11. So it is 11 kV for section V base 3 for section 3. Okay, correct? Then for each system, we must have S. Since the S is given for whole power system, so the S1 is 50, S base 1 is 50, S base 1, 50. S base 2 is again 50 megavolt amp, and S base 3 it is 50 megavolt amp. So for the power system, if you're writing only one is fully enough. S base, no need to mention it one, two, three, because S base for whole power system is something given to you. Okay, the new S base. Then from this point onward, you have to calculate the I base and Z base. So based on these two values for this area, we know the Z base is Z base number 1, which is V2 11K power of 2 over S base, over S base, the new one. Okay, the S base here is 50. So 11 over 50, which is 11 power of 2 divided by 50 equal 2.42, correct? And I base in this, using the Ohm's law, using the Ohm's law, is equal, what is the value? It's, you know, the S is equal square 3 VI, correct? So I need I. I have S, which is 50. 50 divided by 11 divided by, or, okay, square 3, correct? So it is 2.62, 2.62 amp. Is it amp? No, it's kilo amp, if I'm not mistaken, because that one is mega. Yeah, E3. So times E3. Okay, so let's jump to the second uh, section. So Z base for this section is different from the first section since the voltage is different. So here again, 132 power of 2 divided by 50, so is 348.48 ohm, and I, this is for section 2, I base for section 2 is equal the same things, 50 divided by 132 times square 3, which is 218.969. Assume 7 or 69. Okay, working for me. This is amp. And again for this section, which is section 3, since the voltage Z base 3, since the voltage is 11, the same as here, and S is the same, so the Z base exactly the same, 2.42, and the I base 3 also in the same way coming 2.62 kilo. Okay, right now we calculate all the base values. All the base values I calculate. Now we should check whether any of these, any of the given value are different from the new values or not. Okay, let me highlight the wrong value which we should modify. Okay, first, the S of the generator is 50. The S in this system for this part is 50 for the whole system. So the S is 50, correct. The V base is 11. So here the V, which this value, the X given is by the V11. So no need to do anything. The X here is fully correct, acceptable. Okay. Then go to the transformer 50, which is correct. 11 become 132. 11 is 132. So it's also correct. So this value no need to be changed. Then go for transmission line. As you can see, the voltage of transmission line, okay, the voltage that given for the X of the transmission line is 135, which must be 132. So this is wrong. Then the S also must be 50. Here is 55. So it's wrong. So we have to change this X value. This is one of the eligible to rectify. The new value here, the new value for this is equal. Let me open. So Z per unit new is Z per unit old, which is 0.15. There is a J. If you want, you can mention it or just keep it for the end. Times S base new over S base old. S base new is 50. S base old is 55. Correct? Times V base old 135. Correct? Over V base new, which is 132. 132 power of 2. Finally, the final answer here is 135 divided by 132 power of 2 times 50 divided by 55 times 1 point, no, sorry, times 0.15. So the final answer here is 0.1426 per unit. Done. So this is the new. If we are going to use it in this system, we should using this value. Okay. Next, for this transformer, again check. The S is correct, so no need to change. The V132 to 11, again correct. So this value is correct, no need to change. Then for the motor, you can see the S is not correct, must be 50. This is 25, but the voltage is correct. Again, using this formula, the same formula. So the Z per unit is equal. This is for transmission line. This is for motor, for M. It's the old value, again 0.15 times, don't forget this is, there is a J for this one here. So 0.15, a J here. S base new, which is 50 over 25. So the final answer is 0.3 J. So this value rectified by here. This is correct, this is wrong. So if we are going to use if we are going to do anything, means any analysis in this system, the x prime d must be mentioned as 0.3 on behalf of 0.15. Finally, for the load, as you can see, again, this value is given in the 15 megawatts. So for the load, as I mentioned, the P and Q must be divided by S. So the new value of the load in per unit is 15 megawatt megawatt over S. What is the S? Is 50. And then the voltage is in the correct value, so no need to modify the voltage. So the final value here is 15 divided by 50, which is 0.3 per unit. This is P, correct? Then I can change the voltage in per unit. So P in per unit. No V in per unit. V in per unit is actual value. Actual value is 11, as you can see, over V base. So V base also is 11. So the final value is 0.1 per unit. And the cos phi cannot be no need to be considered in the per unit system. It is already in per unit. So then you can see by here the values rectify and modify. Oh, I think okay. Right now I'm following the values here. Okay, the S base consider in this example I give you by myself. Okay, as a 50. Right now, I think in the text, in this text, I wrongly mentioned the value uh, for the S base, which is considered as this one considered as 50 or considered as a 30. So which one is 125 over 30? 50. Correct, correct, correct. I think something is missed by here. I think this one must be 50. This is wrong. This is 50. Okay, this is 50, correct? Yes. So change this one and then this value becomes 0.3. Okay, and then the single line diagram of the system is look like that one. Then again, be careful, since this is the motor for the first two cycle, it is a generator, and the single line diagram of the system is given look like that one. Okay, another example, this is a, I think this system is much more professional. You can see in this system, they miss something as another load, which must be in parallel with, yes, in parallel, this is the load. Okay, don't forget this is this load. This load, where is the load? Yeah, this one. This one is missed. So this value is 0.3, the P equal P, this is P. The V is 1 per unit, 1. So the cos phi is still 0.85 lag. Yes, correct. 0.85 lag. Another G by here. Okay. So done. This is our system. Okay, in this system, you can see we have two generator at the left-hand side, generator 1 and 2, which the neutral point is here. Neutral point is grounded using a reactor. Then a transformer, which the primary side is delta and the secondary side is y directly grounded. Okay. Then we have a transmission line. You can see this is transmission line. Okay, transmission line. Then transformer number 2, which primary and secondary side are y grounded. You can see y grounded. And then at the bus B, we have a generator, generator 3. It's connected in the grounded by reactor. And then we have a motor, the same. So this is our load, this is another load, this is another load. We have three load, two load static. These are static loads. And this one is dynamic, which is a motor and rotating. So for this diagram, again, we should see how many sections we must create. So since we have two transformer, as I mentioned, make it two section, one section, two section. So then you can make, okay, this is section 1, section 2, section 3. Without any data, you can create this one by yourself. So 1, 2, 3, 2, and then 3. Okay, correct? Then what is the question? They said, okay, this is the generator data. This is the transformer. This is the load. This is the motor, which is synchronous motor. And this is the transmission line on per phase. Okay, the value given. Selecting rating of generator 3. This is rating of generator 3 is here. Okay, generator 3 is the base. So values of this one consider as a base. Values, it means this one. Okay, so these two values are considered as a base. So the V base, where is the generator 3? The generator 3 is here, correct? Okay, it's 11 kV. Okay, the V base is 11 kV. Then using transformer number 2 values, change 11 to 33. So here is 33 kV based on this per unit value, this base value. And then the other transformer, which is transformer number 1, change 33 to 6.6. So here is 6.6 kilovolt. Then what is the S? The S for whole power system is considered as, change it to red, how much? 50 megavolt amp. How? Because this is here. 50. Oh yeah, correct. 50 megavolt amp. Okay, it's mentioned by here. Then we should compare the values with this value. Let's see. Okay, oops. Okay, no worries. Let's see. Uh, this one is not 50, correct? If I can return, oh, sorry. I think I have to redo it again. So this part was 11, 11. This part was 33. This is kilovolt, kilovolt, and this part is 6.6 kilovolt, correct? Okay, then just look, the S base is 50 megavolt amp. This is the S for whole power system. Then this one, check. For generator 1, where is generator 1? Is here in this area. The S base is 25, must be 50. So this is wrong, must be rectified. The voltage is 6.6. The voltage must be 6.6, so correct, okay. So this one must be rectified only for S. Again, for generator number 2, which is here in the same things, and same things happen, okay, same. So this one again must be rectified. Generator 3 is selected as a base, so everything is correct, of course. Transformer number 1, the given S is 30, which must be 50. Again, for the transformer number 2, the same things. The voltage level is correct, okay, because we choose it for our means the value of transformer is chosen for the V base. Then loads, okay, these loads, as you can see, the P is not the same. And then the voltage 6.6 for load A, yes, correct, and 11 for this side, again correct. Cos phi also okay. So synchronous motor, which is here in 11 kV. Let's see, where is the synchronous motor? Okay, it's 25 megavolt amp. So this one again need to be rectified, and the voltage is correct. Okay. Finally, for transmission line, okay, we have to find out the impedance in per unit. So let's do all together. For generator number 1, okay, using this formula, let me rectify, Control A, delete. What is the formula we need to memorize? This is the per unit new.